Welcome back, everyone, to lecture 11, where we're moving into something different, and we're talking about um, turning words or sentences or expressions in or phrases into algebraic expressions. Because a lot of times when you're reading story problems, you have to pick out these key phrases and determine how to translate that into an equation to solve. So I don't have too much background for you on this one, aside from, I guess, the major process is to identify whatever variable is in the expression, and then identify what's happening to it or what they're saying to you from context clues surrounding that number. Usually, when they say less, they mean subtraction. More or more than usually means addition. Times, the word times means multiply. It's multiplication. Division's usually explicitly stated. They'll usually say divided by. Times, actually, for multiplication, times or product. A product is what happens when you multiply two numbers together. And then division will either say division or they might say quotient, because the quotient of two numbers is like what happens when you divide. So those are like the big ones for the operations, the algebraic operations that you're familiar with. Addition, subtraction, multiplication, division. And I think that's pretty much all like that you really need to pay attention to. You just have to kind of identify what's happening here to these. So like I said, identify the number and the variable in each situation, and then identify what's happening to it. Okay, so in here it says 14 less than a number p, and we have to write an expression for that in terms of the variable and the numbers. So we have a number p, and the expression says that the number we're talking about, or the expression we're talking about, is 14 less than a number p. So we have the number p here, and then to be 14 less than a number p, we'd have to subtract. Oh, also, I'm sorry, I forgot to add two things to this. Subtraction can also be difference. That might be a word they use for subtraction. For addition too, they might say sum. Sorry, those are the only two I forgot. They might say sum and difference. But back to this, when they say 14 less than a number p, the number we're describing that's 14 less than p is, you'd arrive at that by doing p minus 14, because that, this is 14 less than p. Okay, so the second expression says 17 more than a number r. So we have our number r. What's happening to it? Well, the number they're describing is 17 more than the number r. So to get there from r, we'd have to add 17 more to it. Just like in the first one, we'd have to take away 14 from it because it's less than. But this other unknown quantity that we're talking about, 17 more than a number r, we have to add 17 to r to get there. And that's what we can get from that expression, or from those words. Okay. So in this one, it's a little bit different because they changed the wording a little bit. They're saying 41 is greater than a number y. So we have 41 and a number y. What are we saying here? We're saying is greater than. 41 is greater than some number. So we represent greater than with this symbol, and we're saying 41 is greater than y. That's all that expression is saying there. Okay, and now we have write an algebraic expression for the following phrase. 6 less than the product of 4u and 8v. It's helpful here too, and to consider order of operations. So we have to identify these keywords to see where order of operations come into play more here, because we have product in less than. Less than means subtract, means we're probably going to subtract, because it doesn't say is less than, it just says 6 less than, so that means we're going to subtract. Then it also says product, which means we have to multiply. So when you think about that, we have to think about the order of operations, like how would we combine this? We're always going to put the products together first and then think about what's happening with subtraction. Like we're going to put, the higher order of operation together first and evaluate what it says about that first. So we have product of 4u and 8v. So that means 4u times 8v. Well, we can multiply the variables together just by putting them next to each other, but we can't combine them, but we can combine 4 times 8. This would be 32 uv. So we have 32 uv first, and then our expression is saying that this quantity is 6 less than that product, so that would mean that we'd have to subtract 6 from that product. Like I said, to get that, you'd have to consider where order of operations comes into play. You have to consider the multiplication before you consider addition and subtraction. And product means that whatever two or more words or phrases like follow that, you'd have to consider them being multiplied together. Here it says product, and then it says 4u and 8v, so we have to consider those two things multiplied together. Okay. Write an algebraic expression for the following phrase: 9b plus 8x, comma, divided by 10. Now this punctuation is extra important, that's why I said it. Because we have, when it says comma, that means they want us to consider first 9b plus 8x together, and then divide by 10. So to do this, we'd have 9b plus 8x considered first, divided by 10. Or if you wanted to write it a different way, we'd have 9b plus 8x, the whole quantity, over 10, if you wanted to write it like a fraction. Either way. Okay. So the next one kind of like is oops, I just dropped my pen. Sorry about that. Is a little bit different. It's a little trickier. We have to consider this one in phases and two separate things. Okay, so we have the quotient of q and 7. So quotient means we're going to divide here. And when you're talking about quotient, you always put the first thing listed in the numerator and the second thing listed in the denominator. So this would be q over 7, the quotient of q and 7. The q comes before the and. It's the first thing listed, so it's going to be in the numerator. That's just conventional for listing that. And we know that that's 8 more than the product of p and q. So product of p and q, we know that means we're going to multiply, and then p and q, it doesn't matter the order, multiplication can go either way, so we'd have pq. The important word here that divides these is is. Is means equals when you're talking about two different expressions in this case. So we know before the word is, we have q over 7. Is means equals. We know on the other side of the equal sign, on the other side of is, we have the product of p and q, but it also says the quotient of q and 7 is 8 more than the product of p and q. So in order to get to q over 7, we have to consider this product of p over q, but then add 8 to it, because this expression is 8 more than this expression. So that's what that's saying. That's how you would get to that. This one was a shorter one. That's all you really have to consider. Just consider things really carefully and think about what words mean what. Less or difference is generally going to mean a subtraction between two things. More or some will mean you're adding things. Times and product means you're multiplying. Quotient, or the word division itself, means you're going to be dividing. And then the word is means equals. If you see the word is and then two separate, I guess, like expressions / sentences, then you have to consider them each separately there and see what you'd have to do to each side of that equals sign. All right, well, that's it for this lecture. I will talk to you for the next lecture. Thank you.